morning student, welcome back to math for class 12. Today is the miscellaneous of chapter 5. Miscellaneous of chapter 5. The important example 46, 47 and 48 for board examination. Okay. So now let question number 1. Question number 1. Y equal to 3x square minus 9x plus 5 raised to 9. Okay. 9x plus 5 raised to 9. Differentiate with respect to x. dy dx, this 3 into ddx of x square minus 9 dy dx of x and dy dx of 5. Okay, and 9 3x square minus 9x plus 5. This work is first is second. Okay, I mistake by 9x raised to n minus 1, so n minus 1 this raised to 8. Okay, so n x raised to 1, and then after differentiate of in this side, so the missing 3 into 6x minus 9 plus 0 into 9 3x square minus 9x plus 5 raised to 8. So this multiply 6x minus 9, 6x minus 9, okay, 3x square minus 9x plus 5 raised to 8. That your answer. Okay. Next question number 6. This question number 6. 1 2 years, very simple question. Cot inverse. Let y equal to cot inverse under root 1 plus sin x plus under root 1 minus sin x upon under root 1 plus sin x minus under root 1 minus sin x. Okay, so this multiple of conjugate, this multiple sign upon rationalization. Okay, as in rationalization, 1 plus sin x plus under root 1 minus sin x multiply this plus under root 1 plus sin x plus under root 1 minus sin x upon under root 1 plus sin x minus under root 1 minus sin x under root 1 plus sin x plus under root 1 plus minus sin x. Okay, this is a plus b whole square, cot inverse a plus b minus b, a square minus b square, a square minus b square whole, so 1 plus sin x whole square, square से square root cancel, plus 1 minus sin x plus 2 under root 1 plus sin x into 1 under root 1 minus sin x upon 1 plus sin x minus bracket 1 minus sin x. A plus b, a square minus square से square root cancel. So this is equal to cot inverse 1 sin x hence 2 1 1 2 2 common 1 plus under root 1 plus sin x 1 minus sin x, so 1 square minus sin square x upon minus plus this 1 1 cancel 2 sin x, 2 cut equal to cot inverse under root 1 minus sin square under root cos square x upon sin x. Okay. We continue. Y equal to cot inverse cos x upon sin x, cos x upon 1 plus cos x upon sin x. So use this formula, cot inverse 1 plus 2 cos square x by 2 minus 1 and 2 sin x by 2, this changes to sin x by 2 and cos x by 2. Okay, so 1 minus 1 cancel, so y equal to cot inverse 2 cos square x by 2 upon 2 sin x by 2 cos x by 2. 2 cut or 1 power cos cut, this cot inverse cos x by 2 upon sin x by 2. So this y equal to cot inverse cot x by 2. This is equal to x by 2. Differentiate with respect to x, dy dx equal to 1 upon 2 dy dx of x. This is equal to 1 upon 2. That your answer. Now let question number 7, 8, same type, very simple question. 10 is also a trick 11 question. This is a mix question, okay? This 11 question belongs to 5.4, 4-5 type questions. Okay. So let y equal to x raised to x square minus 3 plus x minus 3 raised to x square. Right? For x is greater than 3. So let x raised to x square minus 3 equal to u, x minus 3 raised to x square equal to v. Then y equal to u plus v, and derivative dy dx and du dx and dv dx, dy dx and this, okay, this one. Let u this, so change in this y function tends to u plus v and derivative this, and let this function. So now u equal to x raised to x square minus 3, taking log on both sides, log u equal to x square minus 3 log x, okay, directly log this, so x raised to x square minus 3 to unpower this side. Differentiate with respect to x, 1 upon u du dx, okay, this x square minus 3 ddx of log x plus log x dy dx of x square minus 3. This equal to x square minus 3, okay, x square minus 3 ddx of upon x plus log x into 2x. This equal to 0, okay. So and du dx equal to u equal to x raised to x square minus 3, this bracket x square minus 3 upon x plus 2x log x. This is equation number 2. And now let question number, okay. Now v equal to x minus 3 raised to x square log v equal to x square log x minus 3, 1 upon v du dv upon dx. Differentiate with respect to x. X is a byproduct rule, dy dx of log x minus 3 plus log x minus 3 dy dx of x square. this x square dy dx 1 upon x minus 3 d dx of x minus 3 plus log x minus 3 d dx out of 2x. Okay, so this function x square upon x minus 3 d dx of this 1 plus log x minus 3 into 2x. So dv dx equal to v cross multiply v raised to x minus 3 raised to x square upon x minus 3 plus 2x log x minus 3. So now putting this equation number 3 from 1, 2 and 3. So dy dx equal to dy dx du dx plus dv dx. This value equal to du dx x raised to x square minus 3. Okay, this and dx equal to raised to x square minus 3 in bracket x square minus 3 upon x plus 2x log x plus v x minus 3 raised to x square and x square upon x minus 3 plus 2x log x minus 3. That's your answer. This is the dy dx answer. Okay. Next question number 11 is done. Question number 13. This is a board examination. Board exam important for board examination. Find dy dx y equal to sin inverse x plus sin inverse under root 1 minus x. Find dy dx. So this is equal to sin inverse x under root this sin inverse. So sin inverse, now let sin inverse x, this change to cos inverse. Okay, this theta, this x and 1, so this is all to 1 minus x square, cos inverse under root 1 minus x upon 1. Okay, so putting, so y, now y equal to cos inverse under root 1 minus x plus sin inverse under root 1 minus x square, sorry square, this is square. Okay, so this equal to pi by 2, this y, sin inverse x plus cos inverse x equal to pi by 2. This function, this value lie in chapter 2. This is formula, pi by 2, differentiate with respect to x, dy dx of pi by 2 is constant, dy dx equal to 0. That your answer. Okay, next question number 15. X minus a square y minus b square equal to c square, number 1, and prove that 1 plus dy dx, 1 plus dy dx, this is square 3 by 2 upon d2 by upon dx square, right? So differentiate with respect to x this function, this x minus a 2 x raised to 1 d dx of this into 1 and dy dx 2 y minus b dy dx, this dy dx minus 0 equal to 0. Okay, 2 common, x minus a and y minus b dy dx equal to 0 and dy dx equal to minus bracket x minus a upon y minus b. This is a question number 2. Okay. Okay, this use. And find d2y dx square minus second ddx of first is 1, okay, minus first ddx of second dy dx b equal to 0, okay, and then b minus b whole square. So putting dy dx from 2 y minus b x minus minus x minus a, and from 2 minus minus plus x minus a upon y minus b upon y minus b whole square. This dy dx, this is dy dx, dx from 2 equal to minus x minus a by b minus. So minus minus plus minus minus plus x minus a. Okay, so this d2 dx square equal to minus y minus b upon x minus b, this b, so this change to b minus taking LCM plus x minus a square upon y minus b upon y, so this y minus b square to power 3. Okay, so now prove this function, putting these values in proof functions. Prove, let 1 plus dy dx is square 3 by 2 upon d2y dx square, this equal to 1 plus dy dx 1 minus x minus a square upon y minus b square minus minus plus, and 3 by 2 upon this function y minus a y minus b square plus x minus a square upon y minus b whole cube. Okay, this value from 1, from 1, okay, this LCM under y minus b square x minus a square upon y minus b square whole power 3 by 2 upon this y minus b square x minus a square upon y minus b whole cube. This value equal to from 1 equal to c square, this c square upon y minus b square whole power 3 by 2, okay, and this value equal to c square upon y minus b whole cube. This factor c raised to 2 into 3 by 2, 2 cut, so c raised to cube upon y minus 2 and 3 by 2, 2 cut y minus b raised to 3, okay, and same upon c square upon y minus b raised to 3, this cut, this value is minus, this minus, okay, this is minus, consider this point, okay, so this equal to cq upon minus c square, that is minus c, which is independent of a and b. You have not a and b function, so that is a b is not here after this proving function, so a b is independent, that dependent on c, okay, this proof. Next question number 16, most important, 15 16 16 important, 16 17 most important question, and cos mostly repeated this question, okay, x cos a minus a plus y, and prove that dy dx equal to cos square a plus y upon sin a, okay, this y function taking in left side, so y left side take cos y upon cos a plus y equal to x, differentiate with respect to x, so second cos a plus y d dx of cos y minus cos y dy dx of cos a plus y upon cos a plus y whole square, right? This dd x of x, this function cos a plus y ddx of cos minus sin y and dy dx, okay? Cos y and differentiate minus plus sin a plus y and ddx of this, so a is constant 0 plus y dy dx upon cos square a plus y equal to 1, cross multiply, this is a cross multiply, this dy dx common, first positive value cos y into sin a plus y minus cos a plus y into sin y equal to cos square a plus y, right? So this dy dx cos a sin b means sin a cos b minus cos a, okay? A and b equal to y or a equal to a plus y, so then equal to sin a plus y, a plus a minus y, this minus, okay, equal to cos square a plus y, so this y cut sin a and dy dx equal to cos square a plus y upon sin a, this is proved, okay? Now let next question or last question, next and last for this exercise, miscellaneous exercise, right? 17 question, important question, most important. If cos, this type of cos x equal to a cos t plus t sin t, right? T sin t, this type 5.6 exercise type question, and y equal to a sin t minus t cos t, okay? Differentiate, find dy dx, right? Find d2y dx, okay? d2y dx, find d2y dx square. So this function is a t function, y function is also t function. Differentiate with respect to t, we get dx upon dt, a directly differentiate ddx of cos t minus sin t, okay, with respect to t, so right, plus t product t second function dd of sin t cos t plus sin t constant dd of t 1, okay? A sin t cut a t cos t बचा dx upon dt, क्वेश्चन नंबर 1, ओके? और यूज करेंगे dt, तो dt अपॉन dx इक्वल टू कितना हो जाएगा, dt अपॉन dx जस्ट अपोजिट 1 अपॉन at cos t, ओके? यूज है नेक्स्ट, एंड dy dt, this function is constant, next year ddx of sin t cos t minus bracket small, okay? This t dd of cos t minus sin t, okay, plus cos t dd of t1 change cos t minus plus t sin t minus plus minus cos t cut on this बचा at sin t, then find dy dx, this is equation number 2, find dy dx dy dt upon dx upon dt, this function dy dt at sin t upon at cos t, 80 cut sin t by cos t tan t. Okay, and find d2 by dx square, d dx of tan t, not a x. Okay, so d dx of tan t, d dx of tan t sec square t, and dt upon dx with respect to x. Okay, t function with respect to x, so this function in term of t, not a x. This is right. So this tan function is sec square t and differentiate, and this respect to dt by this. And from 1 you already changed dx dt, dt upon dx 1 upon this reciprocal. Okay, so putting square t from 1 into 1 upon 80 cos t, right? This is a cos t from 1 d by dx square equal to sec square t into 1 upon cos sec t. This is equal to sec qt upon 80. Your answer. Okay, solve exercise miscellaneous, and any doubt you can ask to me. This chapter also finished, and next chapter will be start of chapter 6, application of derivative. Okay, solve in this way. Thank you.